Good morning, dear students. This is Dr. Priyanka, and I will be discussing experimental research designs with you. And this is the last topic of our research design unit, second unit. For that, once again, have a look at what actually experiment is. This is a research investigation in which conditions are controlled. There would be minimum one independent variable which is being manipulated, and its effect on a dependent variable is measured to test a hypothesis. Basic experimental designs are basic. If only one variable is manipulated, then the experiment is a basic design. One variable is manipulated means we just have one independent variable and one dependent variable, and we are manipulating one independent variable here. That is basic experimental design. But when we actually manipulate more than one variables, this can be concluded as a complex or statistical experimental design. If the experimenter wishes to investigate several levels of independent variable, for example, you have got four price levels and you are going to manipulate them. That means you will be taking four category of one independent variable, then investigating this particular effect. Or maybe you might be having two actual independent variables, not just the level of one independent variable. That can also be considered as having more than two independent variables and one dependent variable. That means our experimental design would be complex experimental design or statistical experimental design. So symbolism we use for experimental designs are basically this way. X would be taken as for the one which is going to face experimental treatment. That means independent variable. O is the observation or measurement of the dependent variable. So that means X here is independent variable for us and O is our dependent variable. If more than one observation is taken, subscripts will be given to indicate temporal order. If you are going to observe more than one observation, then there is a setting for that also. We will be discussing these things in upcoming slides throughout the PPT. Then R is random assignment of test units. For example, either it is an individual or individual company or a group of individual or group of companies. As we diagram designs, utilizing these symbols, the reader should assume a time flow from left to right. The time flow would always be first time and then second time would be on the right side. For example, you are doing experiment in two settings, or maybe for example a pre-test post-test experiment. Then x1 is pre-test and x2 is post-test, so it would be written as x1 O and x2. X1 means previous time, pre-test time, and x2 means the latest time. So time would always be taken as this, from left to right. Some cozy experimental designs. These are one-shot design, after only, one group pre-test, post-test design, before and after, and static group design. Let us discuss them one by one. One-shot design. In this, you are going to observe the value of dependent variable only after the experiment. This is actually called one-shot design. One-shot means you are going for just one shot. That means you will be taking the observation just one time, and that too after only, as the name suggests, one-shot design, that too after only, after the experiment is done. Then one group pre-test, post-test. Pre-test means the observation taken before the experiment, and post-test means observation being done after the experiment has been applied. So O1, dependent variables value before the test, then experiment is being done, X is your independent variable, you have manipulated the value now, and then O2 is the observation of dependent variable after the post-test, after the experiment is being done. So that is post-test. Then static group design. In this, you will be having two groups. One is experimental group, another one is control group. Experimental group would be like this. X is the experiment you have been applying on your independent variable, and then O1 is the value after the experiment. And control group is that group is just being controlled. There is no effect of independent variables manipulation, and O2 is the observation of dependent variable in control group. These were basic cozy experimental designs, and now we have three good experimental designs, we call them. One is pre-test, post-test control group design, post-test only control group design, and Solomon 4-group design. These are basically the replacement of cozy group designs only. We had these three designs: one short design, one group pre-test, post-test design, and static group design. You can replace this one short design with post-test only group, only control group. Over there we were just taking one result, and here we are just trying to say that this post-test only is controlled. So post-test only control group, there it was one group pre-test, post-test group. So when we talk about one group pre-test, post-test, it is pre-test, post-test control group design here. And there it was static group design. Static group design can be replaced by Solomon 4-group design. These are more or less same. Over there we were not going with control group design, but here in every when we talk about three good experimental designs, we are just going with control group designs. So pre-test, post-test control group design would be that you would experimental group would also be measured before and after, and control group would also be measured before and after the experiment is done. But in case of cozy experimental, just pre-test, post-test group design, we were just taking the measurement at both the times. We did not have two groups. Over there only one group was there, but in this case we have got two groups. One is experimental group, another one is control group, and they both would not be knowing about each other. Then post-test only group, again the same way experimental group and control group is there. In case of cozy design, we just had one group, and here we have got two groups, experimental group as well as control group. We will be taking observation of both of them, and then by subtracting experimental group observation from control group, we can find out the difference. Then Solomon 4-group design, again it is almost same as the static group design. Over there we just had one group, but here we had two groups, but it was not a control or experimental group. Here we'll be having two groups, basically four, because in both the groups we will be having one experimental group and one control group. Then in second group also experimental group and control group is there. Again the observations would be taken in the same way. The only difference is there we had two groups because we were just going for just two experiments, and here we have taken control group along with both the groups. So there we have got 4-group design: experimental group 1, control group 1, and experimental group 2 and control group 2. Over there in static we just had experimental group 1 and experimental group 2. This is going to eliminate a few limitations we have from post-test, pre-test. Yes, these were the 6 groups. Let us discuss them one by one with their limitations now. One shot design. What kind of the limitation you might be having in one shot design? You are taking the observation just after only. So what kind of the limitations we might face? We might face limitations like that we do not have any kind of comparison here. We cannot compare any group with pre and post observation. So that's the but this is actually being used in business when, especially at the time of test marketing. At that time you are just going to explore whether it is working or not. That's it, nothing else. You are not going to compare the product with anything else. Then one group, pre-test, post-test. We actually pre and post observe the things. For example, you might be observing people today and then after applying the experiment, you will be observing them after few days, few months, whatever you have chosen for you. For example, uh, you might be observing people in fitness survey or something, some fitness camp. When they came and started with the camp, you have observed them, you have taken their observations, and when they left the camp, you observe their fitness at that time as well, their observations at that time as well. That is also kind of pre-test post-test example. But the only limitation here is that you do not know how people have taken the camp, whether they have taken it, they all have taken it seriously or not. There might be some people who have not taken it seriously, right? So there are so many things, but this limitation can be removed in good experimental designs when we go with one control group as well. But although this design has number of weaknesses, if we go with the weaknesses, but this is maximum used by business researchers. Then static group design. Yes, this is also a kind of good design, in that you will be having two groups, one experimental group and one control group. It provides no assurance that the groups were equal on variables of interest before the experimental group received the treatment. Yes, exactly. Suppose you have taken two groups, one would be going through the experiment, another is not going to go through the experiment, but few people in another group are were more interested in that experiment. They were more physical fitness freak kind of people rather than the experimental group people. So you might get some distorted results. But this particular experimental design has its own good things. For example, you can actually observe two kind of people, like two kind of groups. One is with experiment and one without experiment. So you will get to know the difference. These are again the same with some control groups. So these are actually better than, in every possible way, better than the previous ones, the cozy experimental group, because you are going to implement this with one control group, but this actually increases the cost of experiment. That's the only disadvantage these groups have. But these are having more internal validity than the other groups which we discussed in cozy group. When we talk about cozy experimental designs, one shot design is actually not 100% relevant in every case. So that is being replaced by the post-test only control internal validity group, so that so as to get some things controlled. But all these 6 experimental groups would be designs would be having their own limitations and their own advantages. It depends on what kind of the experiment you are going to have. Accordingly, you will be able to decide that which particular experiment design is better. It always depends on situation, that which experiment group is better than the other. Then advanced experimental designs. These are actually more complex. Number one, completely randomized design. Then randomized block design, Latin square, and factorial. Completely randomized design, an experimental design that uses a random process to assign subjects, test units, and treatments to investigate the effects of only one independent variable. These designs tell us that you are going to choose people randomly. You will not decide it, you will not be judgmental. For example, you might select uh, two classes from a school for your experiment, and you might go with this thing, like one class will be going for experimental group and another is control group. You cannot do that because these people are actually heterogeneous to each other. So you are not going to do that, but you will be choosing. For example, class consists of 100 students each. So what you can do, 50 people from one class would be in experimental design and 50 people from the same class would be in control design, so as to get better results. In this, independent variable can be having different levels. For example, level 1, level 2, and level 3, like this. You can form them in group 1, group A, group B, and group C. You have tried to go with some levels for these groups, and you can formulate this in this way. Like group A, their observation before the experiment and their observation after the experiment. Group B, their observation before the experiment and after the experiment. Group C, their observation before the experiment and after the experiment. In the same way, completely randomized blocks can be experimented this way as well when we talk about post-test. It was with pre-test and post-test, both the groups are there. But when we go about only post-test, then it is like after the experiment, you are taking both the observation. X1 as well as O1. X1 means independent variables observation, and O1 is your dependent variables observation, all for the same group A, B, and C. Group A would be taken after the experiment. Group B's observation is also taken after the experiment, and Group C's observation is also taken after the experiment. Then randomized block design. It is actually the extension of completely randomized design we just discussed, in which a single extraneous variable that might affect test unit's response to the treatment has been identified, and the effects of variable are isolated by blocking out its effect. What we do in completely randomized design, we are randomly taking the sample, right? But here we are actually controlling our extraneous group as well. And this can be presented in this way. Your independent variables and blocking variables would be shown in this way. You can actually control the fast and slow music like this. And you can have two control groups like morning and afternoons, then evening hours. This is how you will be able to block the extraneous variables effect on slow and fast music. Then factorial design, an experiment that investigates the interaction of two or more variables on a single dependent variable. Factorial designs allow for the testing of two or more variables, two or more factors at various levels. Till now, we were just having one independent variable. Now we will be going for more than one independent variable basically. So independent variable 1 is like music, no music, slow music, or fast music. Independent variable 2 can be no music cart signs or grocery cart signs are there. So you can actually put a board for music after the house, after the, just in front of your house or somewhere like that, so that people understand that the music is playing inside the room or something like that. You can give some signs or you cannot give some signs. So it depends on both the things, no music cart signs and grocery cart signs. And one variable is variable 1, independent variable 1 is whether there is no music, slow, or fast music. 3 levels are there. So this way you will be going with factorial designs. There are basically 2 effects which we are going to measure in factorial design. The main effect is the influence of a single independent variable on a dependent variable. That is actually the music. Then there is interaction effect as well, the influence on a dependent variable by combinations of 2 or more independent variables, because we have combined 2 variables here. So second variable's impact is not directly coming, but actually you are trying to measure independent variable 1 and independent variable 2, and then their impact, their combined effect is also being measured. That is basically interaction effect. This way you can go with factorial design tabulated forms. You can plot graphs also. This is 2 by 2 factorial pre-test and post-test for different kind of groups. Or maybe test marketing on price. This is the best example of factorial designs. You will be reducing the price for the product at different levels in different markets, and you will be able to explore it with the help of factorial design then. Then Latin square design, what is it? A balanced two-way classification scheme that attempts to control or block out the effect of two or more extraneous factors by restricting randomization with respect to the row and column effects. In factorial design, we were actually having two independent variables and we were measuring their combined effect as well. But here we will be trying to restrict extraneous variables effect. Then test marketing. Why do we go for test marketing? It is not just trying something out. You are actually putting the product in the marketplace in the market. Actually, it is actually scientific testing. You are trying to launch your product at a very small level in a market which is similar to the market you are going to provide the provide your product as a platform, and you will be trying to check whether the product has been priced well, product's features are good, whether people are comfortable with its pricing, whether people are comfortable with its features, whether people are comfortable with its placement, and everything related to the product can be checked with the help of test marketing. It is actual testing of the product scientifically with some controlled experiment. How is it controlled? Because you are actually placing the product in a controlled market, in a very small market. You are not actually going for the large scale launch of the product. So that is why we call it as a controlled experiment. What test marketing actually is, it is an experimental procedure that provides an opportunity to test a new product or a new marketing plan under realistic market conditions to measure sales or profit potential. You are not going to change market conditions here. You are just we are calling it as a controlled market because we are launching the product in a limited market, in a very small scale market, so as to check whether everything related to product is good or not. Functions of test marketing are: it estimates the outcomes, it identifies and correct weakness if there is in your plan. It would be telling you all the outcomes related to product, whether it was good placement or not. Maybe your product might be having some features which should be added for a better placement, for a better pricing, for better sales. That would also be told to you. You can improve the product with time, or there might be some other weaknesses, maybe pricing related features, so that can be improved at the time of actual launch of the product with the help of test marketing. Lengthy and costly procedure. Yes, it is, but because it is lengthy and costly, so you have to check when not to test and how long should a test last, because these two things would decide whether you are actually going to lose the secrecy of the product, everything related to product or not. It should be on a very small scale and for very limited time period. Otherwise, your product would be out and competitors might try to copy the product, and that too might be at little less cost, and it really costs a lot. When you are going to test going for test marketing, it really costs more than other experimental designs. You can actually identify popular test markets before going to launch the product in test market, and then you can decide a few things. For example, population size, demographic composition of the test market, their lifestyle considerations, whether they matches the product or not. Then competitive situation, how is your competitors situation in that particular market. Then media, then self-contained trading area, or overused markets secrecy. These are the things to be decided before going for a test market. Then control method of test market, you will be choosing smaller city, low chance of being detected is there, and distribution must be forced. You have to take the guarantee that you will be distributing all the products in that market as soon as it is possible, so as to get the test done and come with new ideas. The advantages of controlled method of test marketing are it reduces the cost. Then shorter time period needed for reading test market results. Yes, when you go with smaller city, you go with little less time span, this happens. Or increased secrecy from competitors. Yes, it is, because more the time you take, more the risk of losing the secrecy would increase. No distraction of company salespeople from regular product lines. Yes, some problems estimating sales volume would always be there. Sometimes your product might get over attention, some unrealistic store conditions might be there, reading competitive environment incorrectly, sometimes it happens. Or maybe incorrect volume forecast you have done, adjusted data, penetration and repeat purchase rate, time lapse might be there. So these are the maximum problems we face while estimating the sales volume at the time of test marketing. There are some high tech test markets as well. For example, electric test markets, simulated test markets, virtual reality simulated test markets, but these would increase your cost again. So that's it about all the experimental designs. Let us have some true false. Pictorial experimental, number one, pictorial experimental designs are the least sophisticated type of experimental designs. Is it? These are more sophisticated than basic experimental design. So it is a false. Second is pictorial experimental designs are the, it's a repeat. Next is when a test market is conducted in 5 retail stores in Erie, Pennsylvania. This is an example of a laboratory experiment. Is it? No, it's an example of a field experiment. You are going in field, you are not in laboratory. False. So fourth is between subjects, designs involve repeated measures, because with each treatment, the same subject is measured. Is it? This is actually within subject design. It is not between subject. So false. Next is the question as to whether the experimental treatment was the sole cause of the changes in the dependent variable is the basic issue in external validity. Is it? It is basic issue in internal validity actually. So this is again false. Next, sixth, a maturation effect in an experiment is a function of time and the naturally occurring events that coincide with growth and experience. Is it? Yes, this is true. Next, field experiments tend to have less external validity than laboratory experiments. No, it's opposite actually. So it is false. When the gender of respondents, male or female, is thought to affect in important ways the dependent variable, an experimenter can attempt to block out the effect of gender on the results of the study. Yes, it is. Generally, it is done in experimental studies. So it is true. A 3x3 factorial experiment requires 6 combinations of treatment groups. Is it? 3x3 means 3, 3, 3 each, 4, 3. That means 9. So it is false. We discussed 3x2 factorial experiment and it required 6 combinations. Here, when we go with 3x3 factorial experiment, that means 3x3, 9 treatment groups would 9 combinations of treatment groups would be required. That means it's a false. Last is factorial design allows researchers to measure interaction effects. Yet yes, it allows. So it is true. Self-assessment questions. List the 4 important elements in experimental designs. Yes, you can list them because we have discussed the same question even before. Then list down an example of practical scenario with one dependent, 2 independent, and 2 control variables. We discussed this in previous slides as well. Now you will be having more experimental designs. So you can beautifully answer this question more beautifully than you could reply earlier. Then explain the advantage of a between subjects experimental design over a within subject design. You have to list like what are these, and I mean the definition of both. A within subject design involves repeated measures because with each treatment the same subject is measured. In contrast, a between subject design measure each dependent variable only once for each subject. So there is a difference and you can contrast it. Then compare and contrast completely randomized designs and randomized block designs. Both are basically the types of complex experimental designs. Completely randomized design is an experimental design that uses a random process to assign subjects to treatment levels of an experiment variable, whereas randomized block design is an extension of the completely randomized design. Form of randomization is used to control for most extraneous variables. However, the researcher has identified a single extraneous variable that might affect subjects' responses systematically. So researcher will attempt to isolate the effects of the single variable by blocking out its effect in randomized block design. You can even answer the same with the help of one example. That's it. Thank you. That completes unit 2. In next video, we will be starting with unit 3.